We have a long presentation for half an hour and we're 2 minutes late, so I just have to go through slides fast as I can. J2 Global is a service provider for cloud services. We have fax solutions. If you need a fax line over internet, you can visit efax.com. We also have hosted PBX solutions, eVoice or onebox.com. We have email solutions, and Campaigner is email marketing. If you need to send newsletters to your users or marketing emails, the transmission is guaranteed. Won't go to the spam folders. And Keep It Safe is online storage solution that we have. And also onebox.com, Onebox, which has voice, fax, email, and all that kind of solutions. So today, I'm going to talk about Asterisk deployments, different ways you can use Asterisk, and how we can provide redundancy and high availability using proxy servers. And the things that we can provide with proxy servers: registration, routing, manipulation, rules, and that kind of thing. And if you have questions, feel free. If it's a quick question, I don't mind answering questions. I'm moving forward. If it's a discussion, please leave it to the end. So Asterisk deployments. Well, usually you have some SIP phones, not necessarily always. So SIP phones could be on the LAN at the same subnet as your Asterisk server, or it could be on the internet behind the NAT. You would have some SIP trunks so your SIP phones can call to PSTN or receive calls from PSTNs. You might have some analog or digital gateways. So you can have analog phones connected to your Asterisk server through your analog gateways or analog cards. And you might have digital T1, E1, or even analog PSTN lines to connect to PSTN. And just go back. So in this diagram, we have single point of failure. If your Asterisk goes down, everything is down. This is the point of presentation. What can we do to provide redundancy? So here I have two Asterisk servers that they're redundant of each other, and I have a proxy server that sits in the middle. So all the phones, all your SIP phones are registered to the proxy server. So your proxy server, OpenSIPS or Kamailio, we'll go through the different kind of proxy servers and we'll do a little comparison. But it can be a registrar server. So you register everything to your proxy server. So Asterisk doesn't need to worry about registrations. It improves the performance on the Asterisk server. Asterisk only talks to your proxy server. And all the registration and all your configuration information is stored in the database. So if your one of the Asterisk boxes goes down, proxy server knows to route it to the other Asterisk server. So basically, Asterisk1 and Asterisk2 in this diagram, they're redundant of each other. They could be. You can use them both as active Asterisk servers. So a call comes in, you can distribute the load between both Asterisk servers. And if one is not responding, doesn't have enough trunks, it's not as the hardware crash or there is any failure, the proxy server will route the call to the redundant Asterisk server. I'll go through some call scenarios. I'll elaborate a little more on that. Again, on this diagram, if your proxy server goes down, you still have your network will go down as well. So a better solution would be having two proxy servers, and that would be redundant of each other, two Asterisk server, and also have redundant databases. All this can run on two servers. So the proxy server and Asterisk can run on the same machine. In MySQL, you can install on the same machine and then have two servers that are redundant of each other. So if one hardware fails, the other hardware takes over and it has a copy of your database, it has Asterisk and OpenSIPS or Kamailio running. And if you want to expand on that, this would be your ultimate solution, that you would have a series of proxy servers. They can be distributed across different locations. You can have different groups of Asterisk servers. So again, they can be distributed in different locations. For instance, you use Asterisk for your media, for media proxy. All the calls will go to the Asterisk, but you might have a couple of Asterisk servers that handle all your fax calls, or your data center, or you have development or QA environment Asterisk boxes. So you can have group of Asterisk servers that these proxy servers, they know which phone belongs to what group of servers. They have rules. They know when a call comes in, where it needs to be routed. If that server is not responding, what other servers are redundant to that server. And your databases, again, you can have a cluster. So basically, you would have a fully redundant environment that you have all the control. So I'm just going to walk through a call scenario. Let's say one of our SIP phones, one of our SIP clients, it could be a desktop phone, soft phone, mobile phone, wants to go to PSTN, wants to make a phone call. So the call first comes, so let's say the SIP phone here wants to make a call. So the invite message, the call request, comes to the proxy server, the active proxy servers. And then the proxy servers knows the phone. It can do authentication. It can filter any request that is not intended for that environment. And then when it does the pre-processing, it does the authentication, forwards the call to the Asterisk server. Asterisk says, OK, this is a PSTN call. It chooses to send it to, let's say, SIP trunks. It comes back to the proxy server. It could be the same proxy server or any other proxy server, how you configure. You can have your trunking done with different proxy server, your SIP clients handled with a different set of proxy server. It goes back to the proxy server that you have. So your Asterisk configuration is quite simple. You have only few peers in your sip.conf that basically are the proxy servers. And then when the call comes here, this guy knows how many trunks you have, knows which carriers you're talking to, and you can configure all sets of rules. And all the rules are in the database. And it doesn't have to do database query per call. So the performance is pretty high. Based on the number dialed, it sends it to one of these trunks. And if that trunk is down, it tries the next trunk and so forth. Or it can do distribution amongst the trunks. Or it can have, let's say, I send 50% of my call to carrier 1, 50% to carrier 2. Or you can say, if a call is to a long-distance number or to a Europe country, use this particular trunk or carrier. And if it's for, Asia, use a different carrier. So basically, you have a set of rules that you can use to do your routing. Your rules can have priorities, failures, different time of day, and all those are implemented on the proxy servers. So proxy servers, SPCs. There are lots of SPCs. There are open source versus commercial. This is Asterisk community. Probably you'll be more interested in open source proxy servers or SPCs. OpenSIPS and Kamailio, they're pretty much, they both used to be called OpenSIR. So they have same code base. They're off the same thing. They're very similar. The branch of OpenSIR a couple of years ago, and they're not that far from each other. So take your pick. Doesn't really matter which one you pick. And I haven't heard people have preferences. If you take OpenSIPS, some people use OpenSIPS, some people use Kamailio. They haven't changed that much. There are other choices. OverSIP is based on Ruby. One advantage of OpenSIP is that OverSIP it supports WebSocket. So there was just another presentation, WebRTC. If you want to use WebRTC and have a proxy server, you can use OpenSIP. Performance. So first of all, it simplifies your Asterisk configuration. So you don't need to have all the SIP phones in your Asterisk configuration. You don't need to care about pinging and registration. Everything's done on the proxy server. So Asterisk it would be a lot simpler, and will have to handle less messaging, and therefore it would have much better performance. The OpenSIPS or Kamailio themselves, they can handle over 1,000 calls per second. That's incredible. And also because you don't need to pay licensing fees per channel, it can actually be a stateless proxy server. It doesn't really care how many simultaneous calls you have, and it's lightning fast. So, and then you can also, your proxy server doesn't need to handle the media. So all the signaling can go through your proxy server, but the media can be direct from your SIP phones or for SIP trunks directly through Asterisk server. And that also makes it, creates better performance for your proxy server. Reliability. So as we talked about it, you can have multiple proxy servers. You can use Heartbeat for that and virtual IP addresses. So the active one takes over virtual IP address. If it goes down within seconds, the other one will become active and handle everything, all the registrations, rules, and configuration. They're all in the database. So it provides a lot better reliability. OpenSIPS and Kamailio, they've been around for a long time. Used to be called OpenSIPS, as I mentioned. So they're pretty reliable. They've had their problems over the years, but lots of people are using them, and they're quite happy with them. And you can also proxy media if you need to. There are two modules that you can use to proxy media. So media would also go through your proxy server if you need to. And also management interface. So similar to Asterisk, that it doesn't really have a command line interface, but you can get reports, statistics. Like if you're doing load balancing, you can see at one point how many calls are in each server. You can disable, enable one server. So let's say you have 2 Asterisk servers. You want to change one. You disable, it goes to the drain mode. And when there is no more calls, you can just turn it off, do your changes, and when it's back online, you enable the server. So all that can be done on the proxy server. So what proxy servers can do? So basically registrar server. That's a big job. So let's say you have a few hundred to a few thousand or more SIP clients, mobile app, desktop phones, or cell phones. All the registrations, pinging, NAT traversal, and all that will be handled within proxy server. That simplifies your Asterisk configuration environment and performance. Call routing. So you can have rules, priorities, least cost routing, and reporting. You can have different sets of rules for different times of the day, and everything based on prefix dialing and all sorts of that. So that's something that you wouldn't be able to have as detailed and as simple in Asterisk. And NAT traversal, Asterisk has some NAT traversal features, but in proxy servers you have much more flexibility. You can Every message goes through your proxy server, so you can do any kind of changes. It can detect if it's behind a NAT or not. You can manipulate the SDP, the codecs, the contact header. It has a back-to-back user agent that you can hide your network IP addresses and topology. So the outside, they only see your public IP address and so forth. It takes care of SIP signaling, codec, and digit manipulation. Again, you can change your caller ID. Any source of manipulation you can do. Let's say you want to send calls to trunk one of your carriers, and they need to see +1 in front of your dial number. You just do it there. So if the call is going to this particular carrier, insert a +1 at the end of the dial number. And if a call coming in, it has some extra digits, or you want to make change digits, again, it's possible on your proxy server. Load balancing. You have 2, 3, 4 Asterisk servers. The call comes in. It can do load balancing. It keeps track of how many calls each Asterisk server is handling. And then let's say one server can handle more calls. It has more channels. You can configure all those, and it distributes the call based on your available resources. Or when a call is for a fax, it's a fax call or conference, it knows which servers have what resources and what they can do, and does the routing accordingly. And of course, failure detection and rerouting, and that's the key. So if a trunk is down, a carrier is down, one Asterisk is down, it can detect, it can do pinging, and then automatically it can reroute the call, so you would never miss a call. And on top of all this, you can do your own scripting. Let's say you have some sort of particular feature of your environment that is not supported in these modules. You can write your own script. You say a call comes in, go look up in the database, look at this table and do this query and see if there is enough balance for that particular user before you route the call. So you can do your own scripting and routing as well. So installation and configuration, again, is similar to Asterisk. It's based on, it runs on Linux. It's open source. It has its own configuration and routing script. So for you to do this, you need to know SIP. You have to have some understanding of routing and how SIP works and how your messages and NAT traversal networking. So it's not that anybody can do the configuration. It needs a little bit of technical expertise. It has a bunch of modules, over 100 modules. Based on your requirements, you can choose which modules you want to load and use. And also, most likely, you store everything in a database. You can run without a database, but it's better to have a database and then have everything, like all your rules or your load balancing configuration, your user information, everything, you want to have them in the database, in a redundant database. And so I'm just going to go quickly through some of the modules. I divided them in 3 sections: SIP client related modules. Again, registrar server would take care of your registration, authentication. So the clients can be authenticated. And from security point of view, so you have this proxy server sitting between all your clients and your trunks and your internal network. What does that mean? That means, I'm just going to go back to the diagram for a second. So see what this, how this means in security. So here on the proxy server, when a SIP message comes in, you have all different tools to verify this request, to validate. If it's a call from a SIP trunk, if it's from a carrier, you can examine the IP address, if it has the right IP addresses, if this invite is from a legitimate IP address. If it's a client, you can't, because any client can register from any location. But for clients, again, you can, if you know, let's say you know you're using Cisco phones, maybe you can examine the user agent header or your domain or different headers because you own your client. So it gives you a lot more flexibility to verify a request, to know if this request is legit or not. And so in terms of security, so you filter everything before you send it to your Asterisk server, and it goes to your trunk or PSTN or anything like that. So, and also you can, later we see, you can block attacks. So if you see 100 calls are coming from certain IP addresses, you can look at the ratio and then see if it's more than 10 calls per second, block that IP address dynamically and all sorts of things. So basically it gives you a layer that you can do all sorts of verification of requests coming in. So just going to go back to, presence. So again, if you have BLF, if you're using Asterisk, so Asterisk will have to handle all this subscription and then sends all these notifications. But that all can be handled by the proxy server. And that, again, improves the performance of your Asterisk server. And it gives you more flexibility to send the instant message to presence messages. And then you can do instant messaging, Jabber, JSON, SMS. So instant messaging between the clients, it handles all those sorts of messages. So you can connect to Google Talk or anything like that. Everything, it can use as a cross platform between different protocols. It would, again, it can do NAT traversal. That's the critical part. So when a phone registers, it can examine if the phone is behind the NAT. It can save all the information. And then when the call goes to Asterisk server or vice versa, it can change the message. So Asterisk server doesn't need to worry about, what's the public IP address, what's the local IP address, anything like that. Everything would be handled here. Back-to-back user agent, again, you can use that. That's something that it will let you hide your internal network configuration from your outside settings. So everybody just talk to that server. And again, you can use MySQL, any source of database, ODBC to connect to Microsoft SQL or anything like that. And everything would be saved in a database. So if your active proxy server goes down, the redundant one takes over with the virtual IP address. It's seamless to anybody. The clients don't need to re-register. All the registration information, everything is in the database. So the redundant one just takes over and we're up alive. From trunks and routing point of view, we have dynamic routing or derouting module as prefix space rules. So for rules, you can assign priorities, times of the day, frequency, and then distribution. So you say if it's an international call, I want to use first try my first carrier, and then if that's not available, try the second carrier, or have distribution rules and all sorts of kind of thing. If you can enable drain mode, which is you disable a trunk or a carrier, and then when the calls, it will send any new calls on that trunk or a carrier, and then when there are no active calls, you can do your maintenance work. And of course, it does failure detection and rerouting, Load balancer, again, load balancer can be used for inbound direction or your outbound direction, or both, which is when you have multiple servers or multiple lines that you want to distribute the calls between these servers. And then it also remembers and it can give you reports of which one, what server, how many active calls are on each server. You can enable, disable servers and all that kind of thing. Dial plan is a module that will let you have digit manipulation rules. And you say a call comes in, it has this, it matches this regular expression. I want you to do this sort of changes and rather to this direction. So you can have regular expression, test on the messages and do the changes. SIP messages operations, you can manipulate SIP messages if you want to change the contact header, user agent, IP address, anything. The SIP messages can be changed. Again, you can have NAT traversal configuration for your trunks. And it supports TLS. WebSocket, they're adding WebSocket to Kamailio. Maybe OpenSIPS, they add WebSocket as well. And you can also do XMPP. So a lot of these things, they might be doable through Asterisk or partially doable through Asterisk with a lot of tricks and troubles, but not as much. Like, for instance, the SIP message manipulation. It's very hard to do that with Asterisk and almost impossible. Or like codec changes. And like you say, when a call comes in, like your client has 5 codecs in your proxy server, you can remove, add, or change the codecs you don't like or anything like that before you send it to your Asterisk server or send it to your trunk and all that kind of thing. So it gives you a lot more flexibility and also provides better performance. And then utilities. So rate limit, as I talked, you can use that module to measure attacks, or you can say if I have over 10, 15, 20 calls from one IP address in 1 second, that's an indication of attack, like block that IP address. It can provide statistics, how many messages, how many requests, how many calls, registration, all sorts of that. You can add this. You can look up the statistics you like, or you can add your own statistics to the calls. It also has this NMP interface. It can do SIP capture, SIP trace, and there are 2 modules for capturing SIP trace. It records all the SIP messages in the database, and you can see you actually can see the SIP messages. Will of course slow down the server. SIP capture again is another module that again captures all the SIP tools. It's just were developed with different people. Sorry, rate limit. I mixed up. Pike was where you can detect flood. Rate limit is that a lot of service providers, carriers, they can only handle certain number of calls per second. They give you 500 channels, but they can only do 30 calls per second. And that's something with rate limit. You can assign a call per second limit per trunk. So you have 2, 3 Asterisk servers, all of a sudden they send a lot of calls. Here it knows how many calls it's sending per second and can filter and or reroute the call to a different trunk. If you're passing the rate limit of your trunk. You can use Perl to do a scripting, to do if you have your certain features, requirements, your own database table that you want to look up, do your own rules, everything is possible to do. There is Python as well, and that it will let you do your own scripting. And that's about it. That's for the presentation. So if you guys have questions, Sure.
Can you explain an example of an inbound call? For example, the inbound PID coming in and supposed to go to an IVR and IVR features. Where are the components and which part handles what?
Good question. So inbound call comes in. Let's say it comes in from a SIP trunk. Again, everything goes through the proxy server. So the call comes into the proxy server. It does any verification, manipulation, everything it needs, and sends it to one of these Asterisk server based on your rules. So it says it's a IVR call. I have 2 Asterisk server here for my IVR, so it needs to go to the IVR server. So the call is forwarded here. Asterisk receives the call, plays the IVR. They do their choices, and then let's say eventually it needs to go through a SIP client, to a SIP phone. So that Asterisk server doesn't know the SIP phones, but it knows that my SIP client SIP here, basically my SIP.conf, is this proxy server virtual IP address. So it sends the call here. This guy knows all the SIP phones, all the information are in the database. It knows if they're behind a firewall or not. It knows if they needs to change the message, add codes, remove codes, or anything like that, and then sends the call here. And then when it sends 200 OK back here, eventually the 200 OK comes here, and then the media would be directly from your SIP trunk through your firewall or router to the Asterisk server, and then proxy back directly to the phone or here through your firewall or switch. So the media doesn't need to go through proxy server. And then, but all the signaling would be through your proxy server. Does that answer your question? Sure.
If you have, like, on the SIP clients, basically, if you have them registering against some proxy servers and your high availability floats to another machine,
Correct.
is there ability to save state of your registration, your registered clients, and stuff of that nature?
Yeah, every registration is saved in the database. Okay. So when the other one takes over, it knows exactly when that client registered, when it's going to expire, if it's behind that, source IP, everything is there. Correct, yeah. Sure.
Everything through OpenSIPS, you have one place for your CDR, and so you can actually see everything going on in the organization from one database table.
Very good point. So if you have multiple Asterisk servers, instead of having multiple CDRs, you can look at the CDR on your proxy server, so everything is at one place. Same thing applies to your calls. So you want to see how many, if you have multiple Asterisk servers, you want to see how many active calls you have. You have to look at each Asterisk server to see and then add up together. But if you have a proxy server, you can get all your information at one place because it knows exactly how many clients, how many trunks, how many active calls are happening at the time. Go ahead.
You mentioned error detection. So if you had an IVR application running on your Asterisk, I understand that the proxy server could tell that, say, if Asterisk were completely down. But suppose you had a situation where Asterisk was up and was able to answer the call, but, say, the database that the IVR needed was down. Would there be a way for the proxy server to detect that and, say it answers the call, but immediately then hangs up because it can't move to the next spot? Would it be able to detect that somehow and then route it to, say, a different IVR server?
So the question is, a call comes in here. It has to go to the IVR. So the Asterisk is running, but the IVR application is not running. Invite comes here. Asterisk sends 200 OK, says the call is there. But then IVR is not running. It sends by right away. So here you can, like I say, you can have your rules. So say if the call drop, you can maybe measure the call length and say if it was less than 5 seconds, reroute the call to this other device. Or here, again, you can, even before you send it here, maybe you can do a query or a heartbeat some sort to detect if the IVR is running or not. So you have all sorts of flexibility to detect, to make decisions based on your different environment. Let's say if your IVR has some sort of pinging capability, or you can send it has a management interface. You can examine if it's running or not. You can use that, and then if that's down, you can say don't route the calls to that server, that kind of thing. Go ahead.
Individual modules for OpenSIPS and Kamailio have documentation for each module, but I've noticed a distinct lack of examples on using modules or modules together. Is there a good place to look for tutorials or anything like that, or maybe I'm just not looking?
There are some documentation. There is, but sometimes it might not be enough. One good place is the mailing list. So there's users mailing list both for Asterisk and OpenSIPS. So if something you don't know, you're not sure what's the best way of doing it, you can use the mailing list. Please, before sending an email, really think about your question. Try to explain it, in a reasonable way. Sometimes by the time you type your question, you actually find the answer yourself. So the mailing list, if there are tutorials on the website as well. Like if you go to OpenSIPS webpage documentation, there are modules. If you go down, there are some tutorials like concurrent call limitation, if you want to limit the concurrent calls to some trunk, or but not for everything. Correct. I guess mailing list is one of, if you can't find it anywhere, just post it on the mailing list. Go ahead. The question is, can you speak to the presence module in Asterisk queues, you said? Tell you the truth, I don't know. I know you can connect to the same table in the database, so you can also see the status that Asterisk is setting, but it's not something I've ever tried it myself. I'll be surprised if it can't.
Does this setup work like if you had the proxies at different data centers?
Exactly. So if you have proxies in the different data centers, again, let's say I have two proxies in one location and another two proxies in different location. They can have their own trunks. They can also, so if a call comes in, let's say this data center is all down, then your carrier, that's what they do. They can send it to your other location. They can be active. Most people, that's what they do. But if one location goes down, they can route it to the other location. Your database can be replicated across your locations. So basically, geographically, you have redundancy as well. Go ahead.
So you have a SIP phone registered to the proxy server. Voicemail comes in on the voicemail media server. How does the message waiting indicator get back to the SIP phone to turn the light on?
It just Asterisk sends a notify to OpenSIPS. OpenSIPS says notify is for this client. It sends it to the phone. Simple as that. Or any other message. Sure.
So with that, expanding on his question for the message waiting indicator, or say a presence setting. If I'm subscribing, right now I have an endpoint that's already subscribed to the presence of another endpoint on my OpenSIPS system running by VPN. Again, message waiting indicator, if my OpenSIPS is the proxy port, does the SIP then OpenSIPS subscribe to the notification? Or how do I, am I just missing a step here on how
Actually, so there are two ways that then go into this. Don't want to make it confusing. So when a subscription comes in to the proxy server, you have a choice to just digest it there and take care of presence itself. So don't even send it. Don't bother send it to Asterisk server. But you also have the option to send it to Asterisk server and then let the Asterisk server take care of subscription and generates the notify messages. But for a message waiting indication, let's say you digest a subscribe message in OpenSIPS, you don't bother to involve Asterisk. But if a notified message waiting indication comes in from Asterisk, you can still send it to the client. That doesn't interfere either way. Sure. Yeah. So I guess that's our time. If you have more questions, I'll be around. And thank you very much.